Okay, so for number 20, we have implicit differentiation. We're showing respect to x. Always read this. Never assume, guys. So I get 6x plus, I have to use the product rule, 2 times y, because I got the derivative of 2x, plus the first times the derivative of the second, dy dx, plus 2y dy dx. Remember, it's just an application of the chain rule. Bring the 6x and the 2y over to the right and divide by the 2x and the 2y. Eventually you will get that fast. Okay, so now I can divide everything by 2, so I get the opposite of x, right, plus y over x plus y. Oh, sorry, I left out my 3. So I just get the opposite of that, which is choice B. 21, the table above gives values of the differentiable functions f and g and f prime. Okay, so this is what I taught you today in class. So when you want to get the derivative of an inverse function, you have to find where it's paired with. So we need 4 is going to come out of the g function, out of the f function. So when 4 comes out, -2 went in. So that's what it's paired with, right? So g prime of 4 is 1 over f prime of -2. Okay? So now I go to f prime of -2, which is 4, and then I get 1/4. So that's choice D. Okay, the next question. I want the derivative of 2 to the x. So we had gone over this last week. 2 to the x times ln 2. Choice C. So here they're saying a is a positive number, and I want to get the derivative. So a is some constant, guys. So when I get the derivative, the a just comes along. I get e to the -ax. Then I need the chain rule. So times -a. So I get -a squared e to the -ax. Tangent line. They gave me the point 1, 1, so I already know I have y minus -1 is equal to m, which I'm going to be finding, times x minus x1. Okay, so to get m, I have to get the derivative, and then I'm going to get the derivative at 1. So f prime of x, I have the derivative of the first times the second, I'm using the product rule, plus the first times the derivative of the second. In differentiating the second, I have to use the power rule and then the chain rule. So I have 1 minus 2x cubed plus x times, there's no benefit to me cleaning this up. It's just bothering me. Okay, so now I have to sub in 1. So I get 1 minus 2 cubed. -1 cubed is -1. Then I have 1, and then I have -6 times 1 minus 2 squared. So that's just going to be 1. So I have -1 minus 6, which is -7. So I know the slope is -7. I don't even need to get it into slope-intercept form because I can see the structure. So I want to do the quotient rule here. So I have low, d high, minus high, d low, over low, low. So those cancel out. I get 1 minus ln x over x squared. In this function for number 26, they say that f is differentiable. Well, that also means it's continuous. So let's start with continuity. I'm subbing in 2. So I get 2c plus d equals 4 minus 2c. Okay, that's the first thing. Now I get the derivative, so I get c equals, okay, 2x minus c. But as you know, I have to substitute in 2 for x. So I get c equals 4 minus c. 2c is 4, c is 2. So then if c is 2, let me go back to this. I have 4c minus 4 equals negative d. So I get 8 minus 4 equals negative d. 4 is negative d, d is negative 4. So c plus d would be negative 2. It's like a little scavenger hunt. I don't know. I think it's kind of fun. I wouldn't want to do 50 of them, but one of them is okay. 27, ln of x. So the derivative of ln is 1 over u times the derivative of u. So I just get 1 over x ln x. Number 28, I get the derivative of the first thing times the second thing plus the first thing times the derivative of the second thing. Chain rule, product rule, chain rule. All right, let me take out the GCF. The GCF is the square of x squared plus 2. So I'm left with an x squared plus 2 from the first thing. Be careful with this 3. So I get plus 6x times x minus 1. So what is that? X squared plus 2 plus 6x squared minus 6x. That's 7x squared minus 6x plus 2. So it's choice D, because you have to bring down your GCF, guys. Number 29, let's do the quotient rule. So I have low D high minus high D low over low low. So I end up with x squared plus 1 minus 2x squared minus 2x. I hope I didn't do this problem before. It seems awfully familiar to me. The opposite of x minus 2x plus 1. Oh, the opposite of x squared. My bad. So I get x squared plus 1 squared. So look at the choices, and you could see it's choice C. I think there was a very similar problem. Okay, question 30. You have a cube. Okay, you have the volume x cubed. The volume is increasing at a constant rate of 40 cubic centimeters per minute. Okay, we want to know when. Remember what I told you about related rates? You're always going to have when. X equals 2. Find dx dt. Okay, so do your implicit differentiation, aka chain rule. Okay, so now I'm just going to sub in. 40 is 3 times 4 times dx dt. So I get 40 divided by 12, which is 20 over 6, which is 10 over 3. For number 31, I have in the xy plane, the line x plus y equals k, where k is a constant, is tangent to this other graph here. So if you have a line that's tangent, okay, the tangent line is going to have the same slope, right? So it says it's tangent to the graph, and we want the value of k. All right, so not only is it, if it's tangent, right, to this graph, it's going to have to intersect this graph as well. So we have y prime, whoops. I have y prime is 2x plus 3. Okay, so the 2x plus 3 is equal to the slope, which is negative x there. So I get negative 3x is 3. Okay, So this just means that where this is occurring is at -1. All right, so I know that at x equals -1, this is occurring. And so this line is tangent at this point. So if I substitute in -1, I get y equals 1 minus 3 plus 1. So I get y equals -1. So the tangent line is at this point, and we know the slope is -1. So I have y plus 1 is -1 times x plus 1. Opposite of x, -1 minus 1. So I get the opposite of x, -2. So it's kind of like another scavenger hunt problem. They're not easy, okay? You have to think about what they have, what characteristics do each of these have. So the way I thought of this is, well, this has a slope, right? That is the tangent line. So I have to figure out this derivative, set it equal to that slope, solve for x so I know where this tangent line is, substitute back in, get the y value. Then after I do that, I can write my point slope formula, and then, okay, I can solve for y. Because I want to know the value of k, they're giving me part of the tangent line, but I have to get the rest of it. So, all right, 32. So I have some differentiable function. They give me all this information, and then they say, which of the following must be true? All right, some of this got cut off. So if I have, all right, a differentiable function, it has to be continuous. So I'm looking for guarantees here. So if f of 2 is -5, right, and f of 5 is 5, it did have to pass through 0. Somewhere by the intermediate value theorem. Pass through 0 by IVT. Okay, then it has to pass through 0 again sometime on the interval from 5 to 9, because now we go to -5. So there's another 0. So there's a 0 between 2 and 5, and there's a 0 between 5 and 9, okay, by IVT, okay? So we can guarantee that. Check. Next, the graph of f has at least one horizontal tangent. Well, what would make something have a horizontal tangent? So a horizontal tangent would be where, if you use mean value theorem, right? Mean value theorem tells you the average rate of change has to equal the instantaneous rate of change. Well, 2 and 9 are on this interval 1 to 10, so the slope of that secant line is 0. So the mean value theorem guarantees that there's at least one horizontal tangent. And then they're saying, so between 2 to 5, so let's see, between 2 and 5, do we have to pass through, what is that number? Is that a 3, guys? I believe that's a 3. So if that is a 3, intermediate value theorem would guarantee that. And that's 1, 2, and 3. Okay, that's actually a beautiful question. Very intuitive, and you have to know your theorems. So here we're studying end rate. I'm having a lot of difficulty reading that numerator on here. I believe that is 3n cubed. So it would just be, you would take the coefficients 3 and 1, because those are equal rates of growth. Okay, so for this, I need to have I rock equaling A rock. I couldn't fit the entire question on here. So what I need to do, so 4 times t greater than or equal to 1, the position is given by this function. All right, I need my interval. I have to go look at the question. You know what, I'm just going to skip it and I'll do it in class. So please remind me to go over number 34. 35, the function's continuous and differentiable. Which of the following statements is true? Okay, so let's look through each one. So the minimum value on this interval is 2. Okay, we don't know that, guys. We don't know what happens between, say, 0 and 1. We have no idea. Okay, then the next question is the maximum is 4. Again, we have no clue. So choice C says that the function is always increasing. Well, that's definitely not true. We want to know what must be true, right? And then question D, I believe that says f prime is less than 0. So that would mean that it would be decreasing, right? C was saying that all the values are positive. Well, you can't guarantee that. We don't know what happens between these values. So let's look at choice E. There exists a C for where the slope is 0. Well, yeah, by mean value theorem, since these are the same, okay, A rock equals I rock. Average rate of change equals instantaneous rate of change. So the average rate of change using x equals 1 and x equals 3, that's 0. So the mean value theorem can guarantee that existence, that happens. Okay, the next question is asking how many times the particle changes direction. Okay, so for this one, you just graph it. I'm going to leave it up to you, actually. I'm going to skip it. Graph it and then just see how many times on this interval this function changes sign. So make your x min -3, your x max 3. Your y min, just make it -1, y max 1, because you only care about where this is changing sign, where the velocity is changing sign. Try that. I did one that was similar. Okay, 37. So this got cut off, so I had to type a little bit on the top. Okay, so I have dv dt. Okay, I'm going to get the derivative of the first thing. So that gives me 2/3 pi r dr dt times 10 minus r plus 1/3 pi r squared times negative dr dt. So I'm going to replace dr dt with 6. So what do I get? I get 2/3 times 6 pi r d 10 minus r plus 1/3 pi r squared times negative 6. So that's 4 pi r times 10 minus r. And then over here I get minus 2 pi r squared. Okay, so I'm just looking at my answers to see what would make sense. Okay, obviously they distributed. So I get 40 pi r minus 4 pi r squared minus 2 pi r squared. So that's 40 pi r minus 6 pi r squared. I felt like this was more of an algebra problem. Okay, a little weird. Definitely a little weird. Okay, so the last one, I'm just going to let you guys use your calculator for this. You have to look at the decimals. So we want to know where do they have parallel tangent lines. So we're just going to get the derivatives. So I get 3e to the 2x times 2. That's 6e to the 2x. And then for g prime, I get 18x squared. Just type y1 equals 6e to the 2x. And then in y2, type 18x squared. Look at these answers, okay? So for your x min, why don't you just make it, okay, -1. X max, 0. And you want to know where these intersect. All right? So let's think about it. why don't you just make them go from, let's say if I take -1 and I substitute this in, 18 would be a max there, all right? If I take 0 and I sub it in, 6. So I would just go from y min -2, y max, okay, let's say 20. And you should be able to get your intersection. Thank you, guys.